Okay, special right triangles within trapezoids, all right? Second part of the video series. So what I'd like you to notice here is there's something different happening. We do have a parallelogram, a trapezoid, as you can see by the one pair of parallel sides. And this would be our base 1, this would be our base 2. And in these similar videos and other examples, guys, we were drawing the height straight down. I think we're going to do that too, but I want you to notice that it kind of matches on either side, right? So believe it or not, all right, one of the tough parts of this question is recognizing that they actually gave you the height. Here it is, right? So that height could be, drawn out here, could be drawn in here, right? In any of these positions, all of these would be that 4 radical 6. What I'm going to do is I'm going to draw my height right here. I'm going to, once again, just like we've done in the last couple of videos, I'm going to split up my whole figure into 2 here, right? So figure 1 will be the rectangle, in which I have area equals base times height. And then figure 2, or part 2, if you will be the right triangle, which is 1/2 base times height. So the first thing I wanted you to see was the setup. That's our game plan, right? So let's go ahead and try to label as many side lengths as we can. So as soon as I take a look here, I'm noticing on this left-hand side, I have a rectangle, right? And in any rectangle, right, I guess I can mark this as my other right angle as well. But in any rectangle, we said before, opposite sides are equal. So this length right here is 2 radical 6. And then I'm going to put that 4 radical 6 straight across on the other side here, right? So that means we've labeled all 4 sides and all 4 angles in the rectangle on the left. Now, I want to switch gears. I want to refocus my attention over here on the triangle. So if you can just take a look, we have a right angle. We have 60 degrees, and that makes the missing angle up top there. Whoops. All right, that makes that angle 30 degrees. All right, cool. So we have a 30, 60, 90 special right triangle here once again. So this is going to be my x radical 3 side. Wait a minute. That's not a radical 3. I'm going to make sure I pay attention to that. This is going to be my x side, and this is going to be my 2x. So just to get a plan of attack here, I'm going to go backwards from my long leg to the short leg by dividing by radical 3. Then I'm going to get an answer here for x, and then I'm going to double it. Okay, so let's go ahead and show that. So I have 4 radical 6. Now I got to be careful here, right? So I am going to zoom out a little bit. I'm going to show a little bit of my calculations here, right? So in order to find this side here, we're going to have to take 4 radical 6 and divide it by radical 3. All right, so says our 30, 60, 90 special rules. Guys, once we write this, okay, we can divide radical 6 by radical 3. All right, and that's going to give us radical 2. So now I'm going to write that down, right? So this length right here is going to be 4 radical 2. Okay, finally, I'm going to take that short leg, right? And I know it's the short leg because it's opposite the 30 degrees. I'm going to take that short leg, and I'm going to multiply it times 2. I'm going to double it, all right, so that I get my hypotenuse, and that's going to give me 8 radical 2. All righty. We have labeled each and every side length and angle measure on this figure. So now it's time to go ahead and find our perimeter and area. So I'm going to say it again and again and again. Perimeter is located on the outside. So I only would like to use those outside lengths. So in order to get myself organized here, I'm going to say perimeter equals, and maybe I'll start up top here and go clockwise, right? So we have 2 radical 6 plus 8 radical 2 plus, now I'm on the bottom right there, and I have 4 radical 2 plus 2 radical 6. So a lot of pieces here, huh? And then 4 radical 6. All right, squeeze that in there. Okay, good. Now let me zoom in here, right? So I'm going to use a little bit of color just to kind of draw some attention to things. So if I just look through this expression here, right, I notice that I have radical 6's a couple times, right? And then I have radical 2's a couple times. So I want to make sure that I just combine them nicely, and I'm not squishing them all in together into one term. We're only going to combine apples with apples, right? And bananas with bananas, if you will. So I have 2 radical 6 plus 2 radical 6 plus 4 radical 6. So 2 plus 2 is 4 plus another 4 is 8. So I have 8 radical 6 plus, now I'm going to have 8 radical 2 plus 4 radical 2, which will be 12 radical 2. And then did we have units over here? We did. It was centimeters, okay? So now I'm going to come back and put centimeters on my perimeter. All right, done deal, finished, because these are unlike radicals. We have found the perimeter. Okay, now time for the area. Now we said before we're going to do this in two pieces, okay? So I'm going to have a piece 1 and a piece 2, a rectangle and a triangle. So let's start off with the rectangle first, okay? So in the rectangle, we're going to have a base of 2 radical 6 and a height of 4 radical 6. All right, 2 radical 6, 4 radical 6. Let's zoom in there, right? So let's go ahead and say area equals 2 radical 6 times 4 radical 6. I'm going to keep going with this one. Let's see. So that's going to be what? 2 times 4 is 8. And radical 6 times radical 6 is just 6. So that's going to be, what's that? 8 times 6, or 48. So we actually get a nice whole number here for the area of just the rectangle, okay? But we're not finished, right? We still have to find the area of the triangle. Now, if you notice, the triangle part has a base of 4 radical 2 and a height of 4 radical 6. So let's go ahead and use that, okay? So plus 1/2, right? Since it's a triangle, we have to include the half. 1/2 of 4 radical 2 times 4 radical 6. All right, let's see here. So we're going to go half times 4 times 4. So that's going to give us 8, right? And then that's going to be 8 radical 12. Uh-oh. Hold on a second here. Some people might finish here, right? Some people might stop and say, all right, we're done. We have 48 plus 8 radical 12, but we are smarter than that, right? We're going to take a look here and say, wait a second. We can simplify radical 12 by splitting it up into radical 4, radical 3, which would be square root of 4 is 2, so that's 2 radical 3. Now, careful. Can't forget the 8. All right, a lot of times students forget the coefficient that was there in the beginning. So I'm going to go ahead, I'm going to clarify and finish up my answer. We're going to have area equals 48 plus 16 radical 3 centimeters squared. All right, a little bit of a tough one, a little different, right? We just found our area by taking 2 pieces. All right, let me zoom out. You guys can pause, you can take a look at that. I hope this helps.